So here we've got square roots all over the place, which kind of shouts out at us, think of your Surd rules, think of patterns with square roots. And here we can see that we're having to rewrite this as a power of 3. And we should remember from the rules of powers and indices that anything to the power of a half is equal to the square root of whatever it is. And the general rule is any fractional power is equal to the nth root of that. So if I had something like a to the power of a third, then it's telling me to do the cube root of a. So for this one, it's recognising that k must be a half, because they're saying to write it as a power of 3. So k is worth a half. They're asking us to expand and simplify a double bracket involving square roots and write the answer in the form of, so a classic Surd question. Again, my preference is grid, but lots of people do foil and various other things. As long as you get the same answers, guys, it doesn't matter which method you use. So 2 times 1 is 2, 1 times the root of 3 is just a root 3, 2 times root 3 is 2 lots of root 3, and a root 3 times a root 3 cancels the root out because you times it by the same root to give you 3. If you're not sure why that worked, then remember your rules of Surds. Times in roots, you can put them together into a single root. So this becomes 3 times 3. 3 times 3 we know is 9, and we know what the square root of 9 is, 3. So squaring the same root cancels the root out to give you 3. It's usually the quickest way of thinking about that. And then of course we look for like terms. We've got a 2 and a 3, and 2 plus 3 is 5, and we've got 2 root 3's plus another root 3, which gives us root 3. And then we recognise that the question wanted an integer plus an integer times the root. So we've got an integer whole number plus so many root 3's. 2 root 3's plus root 3 is 3 root 3's. So again, worth checking. They wanted a number times that, so 3 root 3's. So 5 plus 3 root 3 is our final answer.